It's great to see you all again. Welcome to the e-learning course, Development of Diagnostic Skills of Soil Limitation for Sustainable Agriculture. We are now in Chapter 3, getting familiar more with the soil limitation and quality. We all know that good soil is always good for plant growth, right? However, if your soil has constraints or limitation, what should we do? Let me introduce you guys with the soil limitations and soil quality. Soil limitation can be any physical, chemical, or biological characteristic that limits root access to moisture and nutrients or reduce the plant function. Where soil quality describes the properties that make a soil fit to perform particular function. Now you can see that there is some that interface between limitation and quality. And let me explain more about soil limitation first. I give you some example of soil limitation that will include low water and nutrient holding capacity, acidity, alkalinity, dispersion, salinity or compaction, non-wetting soils, and hard setting soils. So diagnosing, understanding, and managing these limitations are major challenges to increasing agricultural productivity, especially when multiple limitations take place in the same soil. Soil limitation may occur in the surface, subsurface, or you call subsoil, and throughout the soil profile. And that is soil limitation. Now, soil quality. Here I like to show the list of the soil quality indices associated with soil ecological function. The soil quality generally is categorized into three groups, which are physical, chemical, biological quality indicators. Now you can see that limitation and quality is really related to each other. But for quality, they are all indeed associated with the ecological function like nutrient cycling, water relations, stability support, buffering filtering, resilient resistance, and biodiversity habitat. Alright guys, now you have two words, right? Soil limitation and quality. Let me explain a little bit more here because the class is trying to simplify all those techniques that somehow is really difficult to measure. But this course is totally for those who are really absolute beginners. So to understand the soil limitation in this class, we will try to use the soil quality indicator approach. So that way you can see how to measure soil quality and try to interpret the result. See if your soil has its limitation based on your soil quality information. And to select those, we have a list of soil quality indicator. We have to select some of those, right? And the way that we're going to select, we like to share you guys with the association with the soil ecological function. That's the first one. The second one is the frequency of the global uses. And of course, the last one, that technique gotta be really easy for you guys to check the soil quality by yourself. Now let me get you more in details. Alright guys, so like I said before that to select those soil physical indicators, we have to keep in mind that first of all, these soil quality indicator gotta be crossed out with the nutrient cycling, water relations, stability support, buffering, filtering, resilient resistance, biodiversity habitats. This table showing you with the first group, which is the soil physical quality. Now you can see the list where we have aggregate stability when wet, bulk density, the depth to the root, remitting layers, plant available water holding capacity, infiltration capacity, and surface crusting. And you see the cross symbol showing that which one is the most related to the ecological function. You can see obviously, right? The one that in the red box now is the soil depth to the root limiting layer. And that is the one that we'll select for the soil physical indicator. And it's gonna be really easy to measure as well. Alright guys, let's move to the second group of the soil quality, and that is soil chemical quality. Here, again, you see the list. The first one is potassium permanganate, The second one is available phosphorus. Next, saturation of phosphorus fixing capacity, available potassium by soil test, soil pH, electrical conductivity, sodium adsorption ratio, total organic carbon, and of course, the cation exchange capacity. I'm not going to explain with the definition in detail for all of this, but I like to show you that the ones that we like to select from the chemical quality is in the red box right now. The first one is soil pH. The second one is the total organic carbon or organic matter. It's work the same. All right. So you see that even soil pH, they're not across those 6 ecological functions, but it's really easy to measure nowadays. You can get the soil test, and we like to show you more about how to test on that in the next following chapters. So keep in mind that first of all, ecological function. The second one is the frequency of global use. I will show you later. And the last one is the most important. Those quality gotta be easy to measure. Now let's move to the last one. Soil biological quality. You see the list again here, but I'm not gonna read for all of you. Okay? The earthworm count is the one that's showing that you see the symbol X across all those 6. And it's pretty easy, right? You go out there in the field, you dig the soil, and then you start counting the earthworm, and that can get you information about soil biological quality. Okay? Now let's take a look on the frequency of global uses that we have to incorporate this factor to select those soil physical, chemical, and biological indicators. Okay? This graph that you're seeing right now is a graph showing that the frequency of the soil quality indicator. The first one is the soil physical quality. You can see that on your y-axis, this is the list of soil physical quality indicator, and on the x-axis showing the frequency of the soil quality global use. Now you can see that previously we talked about the soil depth, right? You can see that about 30% that is the percentage that used worldwide. Now I like to add one more, which is really easy to use your eye to check if your soil quality is good or bad, and that is the porosity. So in this case, for the soil physical quality indicator, we will select based on the soil ecological function, frequency of global uses, and of course the most important one, we're gonna use the one that really easy to measure in the field. With this, we select porosity and soil depth as the parameter in terms of soil physical quality for us to train, and you guys will be able to prove that by yourself later on. Next is the soil chemical quality indicator. This graph showing the same set like previous one, and you can see that we already talked about pH and total organic matter. Now you can see that it matches very well, right? Because pH and soil organic carbon, the frequency of the global usage is really high. Let's say pH is above 80% and total organic matter or organic carbon is above 90%. So we're good for chemical quality indicators. Okay? And the last one is the soil biological quality indicator. Again, you can see that in terms of frequency, it's a little bit lower than others, but we have to keep in mind that we need to pick the one that really easy to measure. Compare earthworm with nitrogen, mineralization, microbial biomass, and soil respiration. The earthworm count probably the most easiest one to do it by yourself. So we get it all. Alright, let me summarize here again. Then the soil physical quality is a maximum soil depth to the root limiting layers and soil porosity. For the soil chemical quality will be pH and the total organic matter. And the last one, soil biological quality, is the earthworm count. Alright guys, we hope that you all understand the approach that we use in this chapter where we're trying to change from limitation to quality, which is really easy to measure. So please keep yourself up to the next chapter. We will coach you all with a series of simple techniques for soil quality checkup. Don't miss it. You all have a great day. Bye bye. See you on the next chapter.